first off, I want to say what a great honor it is for me to be here and be able to participate in this symposium. I think it's pretty excellent. The area-wide folks, it's just been a really great team to work with. And in reality, I mean, if we're going to make any kind of headway with these invasive annual grasses in particular, we really need this cooperative, collaborative effort to really work together, rather than everybody going off in their own directions and there's no real synthesis with all the research and so forth that's going on. And, you know, when we talk about rangeland health assessment or rangeland health, that really means different things to different people. In other words, if you're a wildlife biologist and you're concerned with nesting early brood rearing for sage grouse, rangeland health might be something different, or mean something different to that person, as opposed to a producer that needs to increase cow production or whatever. And so, really, just depending on what your goal is, that can also set the objectives of your management. And so, just going out there and visually seeing that, okay, well, we've got some invasive plants out there, that's the obvious, but what's not really obvious is really identifying the cause of the problem. That's really what we're trying to get to. And so that's what this whole notion is about. And so I kind of like the approach the Marines take, and basically they have a real pretty simple way they approach a problem. Basically, first you identify the problem, and again, that's not always easy. I think Leslie will be talking about site history and so forth and how that can influence on what you're seeing today on the landscape, something maybe happened 100 years ago or more. And so just seeing the weeds out there is not necessarily the most intuitive thing towards what that cause of the problem is. And so once you identify that problem, basically you want to try to identify the cause of that problem, and then ultimately fix the problem. And so basically what I'm trying to do today is just talk about that whole initial identifying the problem, try to get into looking at what might be the cause of the problem, and then I think throughout the rest of the day, hopefully we can get some more information on maybe how we can approach trying to fix the problem itself. And so again, I just want to go through these steps of that framework we've been looking at. And basically, the first thing you need to do out there is basically do this rangeland health assessment. And what that's trying to get you to do is start to think about what causes might be in disrepair, or ecological processes might be in disrepair. So it really gets you to start focusing rather than just going out there and spray and pray that it does some good. And then basically you're into a perpetual spray and pray sort of thing every 2 to 3 years. Again, once you've done that initial assessment, that helps you identify the cause. And then Jeremy and so forth has been talking about principles, and the nice thing that I like about this particular framework that we've been working with is that it's really a living model. In other words, as area-wide folks and other scientists that are dealing with invasive plants, as that knowledge becomes available through research, it can start informing that framework a lot better. And so basically, once you understand the cause of the problem, it kind of helps you basically identify what tools that are needed to address that cause. And so it helps you focus. Remember, we have a toolbox full of tools, and it's important to use the right tool for the right situation, as opposed to a crescent wrench for a hammer sort of thing. And then ultimately, you're going to come up with a plan. And so you're going to see this whole successional management framework over and over again. By the way, I don't know if Brenda told you, but there is a quiz, and you're going to have to fill this thing in. You won't be able to leave until you get 80% or something like that. I would suggest really paying attention to that. But anyways, let me ask you this. How many people have heard of this whole notion of interpreting indicators of rangeland health? Can you raise your hand? So you're pretty familiar with that. And basically, Callan and those folks, this is, I think this is the 2nd edition, or version 4 actually. They're going to be coming out with another one, I think this year, pretty soon here. But basically, they put on a 3-day intensive workshop just dealing with this. And I think it's done usually in the western states twice a year. And so I keep an eye out for that. So I don't have time to really dig into it, but I'd like to just sort of turn you on to the notion of it. And so basically, you're familiar with it. There's basically 3 attributes that are really, dictating the rangeland health. And the first one's basically, site or soil site stability. Basically, you want to keep that soil on the landscape as opposed to, through erosion or wind erosion or so forth. And so, loss of that soil resource is huge because if you start losing that top horizon, that can totally throw you into another state that's pretty irreversible. You start getting into a reclamation rather than a restoration. The other one is basically getting that water into the ground. So what you want to do is get that water into the soil, capture it, store it, and then release it slowly as opposed to having it run off. And then that's where you start getting loss of soil and so forth. And then lastly is basically the biotic integrity. We keep hearing about resistance and resilience and that sort of thing, and that's kind of what we're getting at. And so basically, if we look at these three attributes, we can rate them compared to a reference site. So this whole notion of interpreting rangeland indicators is basically it's tied to ecological site descriptions. And so what we're trying to get at is we're trying to get a reference site that we can compare the same ecological site to this reference site. And so it's basically a point in time assessment. So you wouldn't want to use that like for a trend study or so forth. It's basically a qualitative point in time estimate of what's happening out there today. And so you can put these different attributes into how far do they deviate from that reference site, whether it's extreme to total or none to slight. So again, it's relative to the reference sheet or the reference site, but it's important, what I want to get across is that you want to make sure that your reference site is the same ecological site as the one in question where you're trying to, evaluate it. And so Pelletinol, they basically give a pretty good little cartoon example about just looking at the idea of resistance and resilience. And again, these ecological processes are things that we've been talking about all morning. You're going to keep hearing it throughout the afternoon. But essentially, if we look at just a system that's functioning properly within its normal variation of these ecological processes, we might just sort of be going along in time and everything's functioning pretty well. However, as soon as we get a disturbance, if it can withstand that disturbance with no real detrimental impacts to these processes that we're talking about, essentially we'd say that this has quite a bit of high resistance, right, to change. And keep in mind, this can also be a community that's desirable, or it can be a monoculture situation with reduce ahead. However, if you get a situation where you do get some disturbance, but it's just not able to bounce back off that, essentially we'd say that has low resistance, low resilience. So it couldn't resist that disturbance, and also couldn't bounce back to its normal processes. However, if it does come back, we could say that it has low resistance but high resilience. So that kind of hopefully puts that in perspective. Anyways, the neat thing about the work that Roger and the area-wide team is doing, working with this whole succession management sort of framework, it's really nice to somehow, how are we going to, have some kind of tool or guide to actually identify those causes of the succession that some of those processes might be in disrepair. And so what Roger et al. Did is basically merge successional management with the idea of essentially this range of land health assessment. So they're both two entities, but merging them together makes the whole thing stronger. Now, I'll just sort of give you an example with, in Wyoming we did a lot with sage grouse, and there's a lot of energy development and so forth. And so this is a different type of state transition model that you might be familiar with, but we're just interested in whether a habitat is suitable or not for nesting and early brood rearing. And so we might have a reference site that has your normal bunch grasses and sagebrush, and we might call that high quality habitat. However, with continued spring grazing and so forth, you might start to see a shift where you start to lose the bunch grass component and you get more into the rhizomatous wheatgrasses, thick spike, and so forth. And so it's basically a light disturbance, and this is something that can maybe be switched with management alone. Okay, not a lot of huge input, but it will take a little bit of energy to get it back into that bunch grass system if that's what you're after, if that's your management goal. However, with continued disturbance, and maybe the introduction of a seed source of some annual grasses, you can start to shift into, in this sense, a different state. And even though we've lost our whole, most of our, in this phase over here, this thing works. Over here, we've lost our whole perennial bunch grass or rhizomatous grass component of the understory. In terms of what grass need as far as structure, nutrition, and so forth, basically what they need is structure for safety, and so forth, and forbs and insects and so forth for nutrition. So we still might consider this a suitable habitat, but one's what we call high quality, one we call low quality. However, to get it back into another phase within this state, basically we got to start putting in some energy. So a lot of times it's really difficult to get from an annual grass right back into a perennial grass system. And there's been some work that basically we're looking at crested wheatgrass as a phase to get it back into a native system. So rather than trying to go from a monoculture Medusa head right into a blue bunch, we can take it in phases and just try to get back into a perennial driven system. And then there's work by Jane Mangold and so forth that is looking at trying to get that crested wheatgrass system back into a native system. But EBIPM is going to help us get us back to that desirable state if it's possible. However, with no action, we can get to a disturbance threshold where now we basically just have unsuitable habitat. So we've lost our whole structure component. Basically, we've lost the sagebrush component of it. And so, in that sense, it would be unsuitable. And so, as we do developments or whatever, and those grouse have to shift to something that's unsuitable, that's where you start to see the declines of the populations. And again, it can, without any action, we can start getting perennial forbs introduced into that system. And now you got some real problems because you have monocot and you have dicot, and very hard to deal with. So they're kind of like two different beasts in the same cage. And then with continued no action, you might even get to, well, you can't see it, but desertification. And so with these state transition models, we know that if you look at an ecological site description, if you look at a state and transition model that goes for that ecological site, we know that certain things like fire or grazing or whatever will shift it, or can shift us into a different state that's irreversible, unless you do a lot of energy input to get it back. However, we really don't know a lot of those ecological processes that are going on. You know, what is it about grazing or overgrazing, or what is it about fires, the nutrient cycling and so forth. So these are some of the questions that we're trying to get at, and EBIPM can help us. So anyways, I'm glad that most of you are familiar with the Rangeland health indicators, but basically in 1994, I think it was, the National Research Council got together and they started saying, hey, you know, we're really losing our goods and services that these rangelands can provide. And if you think about how we used to or how we traditionally managed invasive plants in rangeland, most of what we learned is essentially from agronomy, right? But they're totally two different systems. One's monoculture. You know, rangelands have a lot of biodiversity and so forth, so they're basically two different beasts, but we're using the knowledge from agronomy on our rangelands, and you know, those things are still expanding at their biological potential. So anyways, these 17 indicators with the Rangeland, the Research Council came up with, is we need to start looking at these indicators, of multiple indicators, to get us in line with what these rangelands are doing in terms of their health. And so essentially what they've done, if you're not familiar with it, is basically each one of these 17 indicators of rangeland health is associated to one of those three attributes. Okay, so, and like for instance, if one indicator is going to start getting a lot of rills or so forth, you're starting to see some soil erosion, that's going to be associated with soil and the hydrologic aspect of it. And so anyways, what you go through, and you basically rate these 17 attributes based on what your reference sheet is. Does that make sense? So it's relative to your reference sheet or your reference site. And so once you've gotten those ratings, either the 4 ratings that I told you, none to slight, or moderate or heavy, it's basically that deviation from that reference state or that reference ecological site. And so really what you're trying to do basically is the first step is to go out there and actually try to assess what's going on. And I really recommend getting together with everybody that you can, the producer, the soil scientist, the botanist, anybody that you can to get out there to help you identify what those causes are. And so basically, the first thing you're going to want to do is, like I said, you want to determine your ecological site. That's really important. So this is all relative to a particular ecological site, like a 10 to 14 inch loamy ecological site. So you basically determine what that ecological site is that you're going to be working on. You find the same ecological site that can be used as a reference site. Does that make sense? So your ratings are going to be relative to that reference site. And basically, at that point, you're basically trying to determine the soil, the ecological site, and basically any information that you can come up with. In Wyoming, there's quite a bit of the central portion of Wyoming. The NRCS hasn't mapped those soils, and so you don't have ecological sites for a lot of those. Some of those counties, Salt County and so forth, or the Carbon County. But what you can do is that you can get with the NRCS, and they actually have, even though they haven't totally mapped out maybe the area where you're in question, you can get a key to do it yourself, but it's basically like a dichotomous key that you go through, and you sort of texture the soil, dig in, 20 inches into the soil, and you can kind of go through a dichotomous key to help you identify what ecological site that you're on. And so that's really the first thing that you want to do. It's really important to use a reference site that's similar to the site that's in question. So anyways, the next thing is basically, with these new ecological site descriptions, they come with a reference sheet with it. So basically they go through the 17 indicators and they tell you what to expect. And so when you go out there to evaluate, then you're comparing it to that reference sheet. Does that make sense? So anyways, a lot of times, like I said, some of these areas may not have been mapped just yet in your area. And so that's when you're going to really have to kind of dig up the information on your own. So that means talking to producers, talking to resource specialists and so forth. And basically, you're trying to come up with all the information that you possibly can about that particular ecological site. I mean, what's its potential? So that your management goals can essentially be realistic. If you're dealing with an ecological site, like say a shallow calcareous, 9 to 14 inch precip zone or whatever, it only has a certain potential. So to say that, we're going to get it back over to some state might not be realistic. So anyways, once you've gone through and you've rated these 17 attributes as far as how they compare to your reference site, what you can do now is basically come down and start filling in this lower portion. You're trying to basically identify, is it the soil, are you losing soil, or is the water not getting into the soil, or are you losing biotic integrity, and so forth. And so basically, you're getting these ratings and applying them here. And like I said before, each one of these attributes, indicators, is related to one of those 3 attributes. And so eventually, when you go through the whole system, you can kind of hone in on what of these 3 attributes are really of concern. what might be the cause of the problem. And so again, you kind of got to use your professional judgment. It's a point in time assessment. It's qualitative. You can use quantitative measurements like line point intercept or that sort of thing to get some of these indicators. But basically, it's a qualitative sort of thing. It's a point in time. It's just what's happening today. And you're just trying to get an idea of which of these three attributes, if not all, are of concern. So once you've done that, what Roger has done is basically he's merged these indicators of rangeland health with successional management. And so what he did is basically grouped all the indicators that really have to do with soil and pretty much address these other ones. So basically, there's not 17 indicators here. What we have is the group right into this bunch right in here for the soil site stability. And what you can do now is basically go through and based on your assessment, go through and actually try to rate these different causal successions and try to come up with an idea of which one of these three, if not all, are need repair or need to be addressed. And so in this instance, we're not seeing a lot of site availability is slight to moderate compared to the reference site. However, species availability is extreme on a lot of these, especially invasive plants. And so what it's saying basically is that you probably lost quite a bit of your desirable species, and essentially you're left with undesirable. So if you go out there and spray and walk away and not try to fill that niche again, guess what's going to happen? It just comes right back, right? So it's helping you identify those processes that are really need to be addressed. And so anyways, I borrowed this from Roger, but I think it sums it up pretty well. Essentially, we know that communities change. That's why we have state transition models to help describe that. But the thing is when we start doing these restoration projects and so forth, we really want to try to dial in to those causes and address those processes that influence those causes, so that your management is valid for long term, as opposed to getting into the perpetual spray and pray every 3 years to where it does get expensive. Anyways, I kind of went through that pretty quickly. In 20 minutes, I can't really go through a whole lot of it, but I recommend if you go on to the BLM technical references, just Google it. You can get the book online for free, basically just download it. And then again, they do have that workshop. It's an intensive 3-day shop that they really get into it. And then I recommend looking at edipm.org, and you can find some more information on that as well.